Picture this. You're descending into absolute darkness. The pressure around you is crushing, hundreds of times what you experience on land. The temperature hovers just above freezing. There's no sunlight, no plants, no refuge. This is the deep sea, and by every measure of logic, nothing should survive here. Yet, something moves in the darkness. A shape emerges from the void. At first, you think it's a small creature nearby, but as it approaches, you realize with creeping horror that this thing is massive. What should be the size of your thumb is now the size of your arm. What should fit in your palm could swallow your head. Welcome to the realm of deep-sea gigantism, where the laws of nature seem to flip upside down, and the abyss transforms ordinary creatures into living titans. Today, we're diving into one of the ocean's most disturbing mysteries. Why does the deep sea create monsters? Let me introduce you to something that will haunt your dreams. The giant isopod, Bathynomus giganteus. Now, you know what an isopod is. You've seen them. They're those tiny pill bugs that roll into balls in your garden. Harmless, cute, even. About the size of a grape. But take that same creature, drop it 2 kilometers below the ocean's surface, and watch what happens. It grows, and grows, and grows, until it's 14 inches long, over a foot of armored, segmented nightmare fuel that looks like it crawled out of a Paleozoic fever dream. Some specimens weigh 4 pounds, as much as a chihuahua. This isn't an exaggeration. This isn't a different species that just looks similar. This is the same basic body plan, the same genetic blueprint, the same type of creature, just impossibly large. And here's what should keep you up at night. We have no complete explanation for why. Oh, we have theories, hypotheses, scientific educated guesses. But the truth is, the deep sea has taken the rulebook of biology and shredded it into confetti. The question isn't just why are they big? The question is, what laws of nature are we missing? Here's where it gets truly bizarre. Everything we know about evolution suggests that larger bodies require more energy, more food, more resources. It's a simple equation. Bigger size equals bigger appetite. So logic dictates that in an environment of extreme scarcity, like the deep sea, where food is so rare that creatures can go months without eating, organisms should shrink, become more efficient, minimize their energy needs. The deep sea should be populated by tiny, energy-efficient organisms eking out a meager existence in the dark. Instead, we find giants. Giant squid with eyes the size of dinner plates. Spider crabs with leg spans reaching 12 feet. Amphipods, normally the size of a grain of rice, ballooning to 7 inches long in the Hadal trenches. It's as if the deep sea looked at the fundamental principles of energy conservation and said, no. But nature doesn't break its own rules. It just has rules we haven't discovered yet. Let's start unraveling this mystery. The first piece of the puzzle is temperature, or rather, the absence of temperature. In the deep sea, the water hovers between 2 and 4 degrees Celsius, just above freezing. And this changes everything. You see, temperature isn't just a number. It's molecular velocity. It's the speed at which chemical reactions occur. It's the pace of life itself. In cold water, every biological process slows down. Metabolic rates plummet. A giant isopod's metabolism can be up to 70% slower than its shallow water cousins. This is called the metabolic cold adaptation hypothesis, and here's why it matters. If you're a cold-blooded creature in near-freezing water, your body burns energy at a glacial pace. You don't need to eat as often. You don't need to hunt every day. You can afford to grow larger because the cost of maintaining that large body is dramatically reduced. Think of it like this. Imagine 2 cars. One is a gas-guzzling SUV, the other is a hybrid. In a world where gas stations are everywhere, the SUV is fine. But in a world where gas is impossibly rare, only the hybrid survives. Now imagine the temperature drops so low that the hybrid only needs to refuel once a month instead of once a week. Suddenly, you can afford a bigger tank, a bigger engine, a bigger body. But temperature alone doesn't explain everything. Because if cold water was the only factor, the Arctic Ocean should be full of giants too. It's not. There's something else happening in the deep. Here's a fact that seems to contradict everything. The deep sea is rich in oxygen. Wait, how is that possible? Oxygen comes from photosynthesis, from plants, and there are no plants in the eternal darkness of the abyss. The answer lies in the ocean's circulation system, a global conveyor belt of water that scientists call the thermohaline circulation. Cold, oxygen-rich water from the polar regions sinks into the deep ocean, carrying with it dissolved oxygen from the surface. This water is so cold and so dense that it settles at the bottom, creating a reservoir of life-giving oxygen in the darkest depths. And this changes the game entirely. Oxygen is the limiting factor for size in most ecosystems. The bigger you are, the more oxygen your tissues need. Insects can't grow beyond a certain size on land because their respiratory system, those tiny tubes called tracheae, can't deliver oxygen efficiently to a massive body. But in the deep sea, oxygen is abundant. The water is saturated with it. And because the cold water slows metabolism, creatures need less oxygen per unit of body mass while having more oxygen available. It's a perfect storm for gigantism. The giant Japanese spider crab, with its 12-foot leg span, survives in waters between 150 and 800 meters deep, right in the sweet spot where cold temperatures meet high oxygen levels. The colossal squid, the largest invertebrate on Earth, hunts in the frigid waters of the Antarctic, where oxygen-rich water descends from the surface. But there's still another piece to this puzzle. Because size isn't just about having enough oxygen, it's about surviving. In the deep sea, food is spectacularly rare. A single dead whale falling from the surface, what scientists call a whale fall, can sustain an entire ecosystem for decades. Creatures will travel enormous distances to reach these oases of nutrition. But between these bonanzas of food, there is nothing. Darkness. Void. So how do you survive in a place where your next meal might be weeks or months away? You become a living storage unit. Larger bodies can store more energy reserves. A giant isopod can gorge itself on a rare food source and then survive for 5 years without eating. 5 years. Try to imagine that. A creature that can fast for half a decade, its metabolism so slow, its energy demand so minimal that it can afford to wait in the darkness, motionless, until the next feast arrives. This is called Kleiber's law in reverse. Normally, larger animals need more food. But in the deep sea, larger animals are better at not needing food. Size becomes a survival strategy. And there's another advantage, predator avoidance. In the pitch-black abyss, most predators rely on bioluminescence or chemical cues to find prey. A larger body means you're harder to swallow, harder to kill, harder to drag away. You become too big to fail. But here's the truly unsettling part. We're only beginning to understand these mechanisms. Every expedition to the deep sea reveals creatures we've never seen before. Creatures that challenge everything we thought we knew about the limits of life. The deep sea covers more than 60% of our planet's surface. It's the largest habitat on Earth. And we've explored less than 5% of it. Every time we send a submersible into the abyss, every time we drag a net through the Hadal trenches, we find something impossible, something that shouldn't exist by the rules we've written. Giant isopods the size of house cats, amphipods that dwarf their surface cousins by a factor of 30, tube worms that grow to 8 feet long, living for centuries around hydrothermal vents. These aren't anomalies. They're not freaks of nature. They're the norm in the deep sea, which forces us to ask, what else are we wrong about? The law of the depths isn't that the abyss creates giants. The law is that we don't understand the laws. Every creature we discover down there is a reminder that nature is more creative, more adaptable, and more alien than we ever imagined. That the same planet we walk on every day contains realms so foreign, so extreme, that they might as well be on another world. The giant isopod isn't an aberration. We are the aberration, surface dwellers who have spent our entire existence in the thin, warm, sunlit skin of the ocean, believing that this narrow band of conditions represents normal. But normal is relative. And in the crushing darkness of the deep sea, where pressure could flatten you in seconds and the cold would stop your heart, giants walk, or rather they scuttle, slowly, deliberately, waiting in the dark for the next meal that might not come for years. The abyss keeps its secrets well, but we're listening now. What other mysteries lie in the deep? What other laws of nature have we misunderstood? Let me know in the comments below. And if you want to dive deeper into the strangest creatures on Earth, check out the next video.